Hello! That was a very abrupt transition. But we are here. I am here, and I'm tired of waiting. I don't want to just sit and let the song finish playing. Oh boy. Okay. So, we sent out the stream invitations. We have a Discord bot, which is not working. But we're here for a second stream. And we've done so many things. Look at this checklist of complete things that we have. We're so good at programming. Okay, so I'm very nervous because I don't know what's going to happen this stream, but I should start by just staring at what we have so far. If OBS would cooperate with me. Okay, yes, OBS will cooperate with me. Okay, so if we choose a file, and cool, and then we hit play, it visualizes we see the sounds. Right, we see the sounds. It's probably a little bit loud actually. A little bit concerned, dropping that down. Yeah, so like mission accomplished, right? But ultimately the goal is to make this look cool. And so far it is a line in a box. It is a wiggly line in a box. We must do better. We must do more with this. So that's what I'm going to try to figure out today is what is more? What possible more is there to do? And maybe I'm going to clean up the code a little bit. I don't know. So let's start staring at the code. Let's start staring at the code now. Oh, and I replaced my mouse. I now have a mouse that hopefully doesn't have a scroll bar that does weird stuff like flicking up and down for no reason. Okay, what nonsense did I write those couple days ago? Holy cow. Let's see. Let me think. So you know what we need to do is... Oh, hey, a chat member. Welcome. Thank you for visiting. So happy you're here. What I'd like to do is make the... Okay. What I'd like to do is make the box that the visualizer shows up in. I need better logic to pick that box than what I currently have. Okay, which is... Where is it? Okay, it's this. This is my function that maps sample number to X and Y, and it needs to not be what it is currently. Chat member asks, could you separate it by frequency range and then have them be different colors? Yes, totally I could do that. All I would need to do is figure out how to determine the frequency of the sound based on just the sample information. And my problem is I don't super know how to do that. Or like I think the way that people typically solve that problem is using a fast Fourier transform. And me lacking the knowledge of how to do that, I would have to like get a library to do it, or I'd have to learn how to do it. And I want to do the same thing as that, but in a stupid way first, in a non-fast Fourier transform way. That is one of the things that I plan to do, is determine the frequency of a... I mean, look, I can prove it to you. I can prove that was my plan all along, because, look, it's right there. It is in my notes.txt, therefore it proves that I knew this all along. So what I want to do. Can I write a function that does the thing? It was written, that's right. So I want to stare at this for a little while. I want to stare at this for a little while. So, right, what I actually need is my linear mapping function from another program I wrote. Do I have that just on my PC? Can I, during a live stream, bring out the linear mapping function that I wrote before? Come on. Oh, I'm pretty sure I can, actually. Give me a minute. Stream? Where is it? This is gonna be faster if I can find it. Huh. I can't find it. Oh my goodness, where is it? Alright, so we're gonna try to recreate that function, I suppose. Which might be ill-advised, but we're gonna make it happen. Okay, where do I want to stick this thing? I always end up making this is the natural progression of my project, is I first write everything in the index.ts and then I make a util, and then it's all downhill from there. Let's see. Okay. This might be a complete disaster. But the goal of a map linear function is you have a value in some space, some number line. Yeah, that's a way to think about it. Okay. So you want to map from one number line to another number line. And the problem is that those two number lines could have different starts and ends. So I'm trying to remember. I could rederive this, or I could try to remember how I did it before. I think what I did is I take this value, I try to convert it to a percentage. Right? I try to convert it to a percentage. And I want to try to not assume which one of these is bigger or smaller, but I think I'm going to have to. Because you could, right, you could do, you could do this. Okay. And now we have a percentage, which is not really tied to any particular number line. And then I want to map it over to the 2. So it would be like this. Yeah. Pretty sure this is totally wrong, but if I just use it carefully, we'll be all good. We'll be all good. So I can come over here and use my magic map linear function and do something. So I want to take this I and map it into the X space. So I know that I is always going to be between low and high. And my destination is kind of whatever I want it to be, but I should go ahead and declare some variables for that. Probably 0. I need the top left X and Y and a width and height, I think. Maybe I want to do X min, X max. Y min, Y min, Y min. 750? Okay. I've just written this, and I know why I've written it, but now I see there might be a problem with it. Because... what am I thinking? This should actually be, my problem is that the Y, is inverted. So I'm not sure what I'm gonna do about that when it comes to using this great little map linear function. But I know the x min and x max. So that should basically solve that for me. And I suppose I can test this. Oh, that's a bad sign. Yeah, okay, something has gone terribly wrong. Also, I did not get an error message for it. I do this minus this, and I do that minus that, right? Let us begin debugging. That actually seems pretty reasonable. I don't know what the big deal is. 0 maps to 0, 1 maps to 4, 2 maps to 8. Huh. What is the problem? I don't understand. Alright, mess with the log statement a little bit. Okay. Ta-da! We get like 1,000 print statements. This is so perplexing because all these x and y values look totally fine. I assume that it's drawing it off screen right now. That's what I assume. Huh. Okay. Maybe my cute little log counter idea is actually not what I want, and I do just want it to spam spam to everything. Oh, hey, look at that. Okay, there's the problem. It's not like it letting me stop it. Help. Help, please. The browser won't stop running. I need to kill it now. Like, it won't. My poor computer. I've never been not been able to stop it before. This is kind of funny. Okay, there we go. I did it. I killed the beast. The beast's reign of terror has ended. Let's try opening this. Let's try doing this again. I need that window up. But we figured out the problem. Well, we reproduced a problem, is what we did. Which is half the battle. And now if I come over here... Yeah, okay, the window is... OPS did not explode. Okay, OPS is happy. Okay, so what's happening is... When we print out... What are we printing out? I believe it's this. Right? We print this out, and it's a really big number. I think that's what's happening. Is that what's happening? Frick. I don't remember because I just closed the log window. Oh, gosh. Let's do some obscenely large number with the knowledge that it will at least stop eventually, right? Oh, jeez. Okay. No, yes, for sure. For sure this is... Because the second value is the x value. The first value is the y, the second value is the x, and the x is a very large number. Okay. That is for sure the problem still. I hope I will get control over my computer again. Yes, I do. I do get control over my computer again. That's great news. Yes. Cool. Yeah. Okay. X value too big. Which honestly does not make sense to me. Oh, no, it does make sense to me. Okay. I'm stupid. I did high minus low. I divided by high minus low. That's totally wrong. That's totally wrong, I think. Because I need to do... this minus start. Before I do that division. Yeah. Yeah, that should totally work. Mission accomplished. Oh, I still have all the print statements there. That's fine. We'll just let it do its thing. Also, you can't hear it, but that's fine. I can't either. Here we go. Yay! We made it display larger because we have a non-broken map linear function now. We're very happy about this. Alright, you've had your fun. I'll probably need this again. But now all we want to do is switch the Y to use the map linear. Switch the Y to use the map linear. So the map linear for Y, geez, okay. Well, it's basically the same thing, right? It's the same concept. Well, wait, hold on. It's not. It's the sample thing that we're mapping. Okay. Right. And the sample can be -1 to 1. Yeah, this might do it. Yeah, choose a file. So we've got like 0.3 here, and that maps to a Y value of 488. Now, is that actually the number we expect? Well, wait. Okay, we could just compare these two, right? This is a higher number, and it has a Y value that's higher. And this is a lower Y value. It has a lower Y value number. This is a lower sample. Yeah, it seems like it's working correctly. I was very worried that it would like have reversed the Y, but no, this seems totally correct. Cool, great. Perfect. Okay, so this gets to go away. This gets to go away. Our map linear function is now understandable, or our drawing code is now more understandable. Yay! Now what should happen next? I did the map linear thing. Let me stare at this. I don't think that's gonna work. No, it's very unhappy when I do that. I could draw it with a thicker line, for one thing. I could change the color of the line, but that's not exactly... Yeah, I could jump right to the trying to determine the frequency thing. That is definitely the harder thing, and I'm kind of like putting it off, I guess. Well, I wasn't putting it off before. The map linear thing needed to happen, but... Yeah, okay. How can I do that, though? So one thing I need to do is, if I'm gonna do some sort of ad hoc method of determining the frequency, I want to take what do we call this? What do we call this like instance of what's on the screen? It's like a sample of samples, a subset of the samples, a window. We could call it a window. We take a window, which is a sequence of samples, like 400 or something. I'm not sure. I don't remember how many we have there. We take a window of samples, and my concern is that we don't know what like the peak looks like. So what we could do is kind of multiply by something so that the max is always 1. It's a little bit weird because the min, what if the min is not -1, you know? But the max is 1, or some variation of that. That's weird. So I do like the, what would I do? I take the max of the absolute value over all the samples, right? I could do that. Yeah. It's a little bit weird that this audio timer is still going. I wonder if that's bad. I wonder if that means I've done something wrong. I don't know. I'm sure there is some synchronization issue, but that's an issue for another time. Okay, so let me start by trying to find the max, I don't know, the amplitude, up or down amount, which should be relatively easy. This sort of has to be as like a pre-processing step. Yeah, this has to be like a pre-processing step that will reuse the low and high thing. So one thing we could do is, just for the fun of it, we could multiply every sample by the, what is it? Max amplitude is going to be a number less than 1 most of the time. So if we do 1 over the max amplitude, then that will make it, I'm stretching it out. What would you call that? It's kind of like dynamic leveling, I guess. I'm removing all dynamic elements of the song. It doesn't actually do that to the audio. It's just the visual display of it, though. I mean, I could go in there and mess with the samples that get played, but then that would be a lot harder to deal with, like synchronization and stuff. I'm not going to do that. Because this is just a test. This is just to see that the code I've written so far works. Yeah! See, it's much bigger. Absurdly so. Also, I'm pretty sure... Gosh dang it. I think this is a visual bug, because it's not supposed to... Let's see. Let's come back over here. The min and max must be a bit wrong, because it's supposed to be drawn not overlapping this top part, but does overlap this bottom part. I mean, actually, I kind of don't want it to overlap this bottom part as well, because I've got this samples counter here. So maybe I fix that bug. Does that magically make it work? No. No, it does not. No, it does not. Okay. Why does it not? Do I bring back the console.log? I don't know that I do. Let's go back over here. Alright, map linear function, what is your deal? I think part of its deal min max. Huh. It should only be able to map it to a function, to a number that's within here. What the heck? I do y max minus y min. Sample minus -1. So if the sample is -1, then we get 0. Oh, is that right? Oh, okay. I actually want to do 2 start plus this. Yeah, there we go. That does it. Fantastic. Fantastic. We're very happy about that. You know what occurs to me is I could do a cute little visual effect right now with what I've got so far. So like this whole max amplitude concept that just proved that it works approximately how I want it to work. But I could do a cute little visual effect. Let's check this out. Line width. Another map linear. Why not? Max amplitude could be between 0 and 1. And let's map it to a number between 1 and, I don't know, 20? And set that as the line width? That could be cool, right? I kind of can't tell if that's working. I think it is. Yeah, I'm pretty sure that's working how I thought it would. Yeah, I like that. I like that a lot, actually. Yeah. Alright, that's cool. That is cute. That is as cute as I expected it to be. Okay. We have a max amplitude. We can we can do like a normalization of the audio window. How can we determine the frequency of a particular audio window? Or like, I don't know, the main frequency of it. It's kind of... I was thinking about this the other night. You know how, like, think about a sine wave. Is that the right way to think about it? Yeah, think about a sine wave, okay? And you're trying to measure the distance between any two peaks of the sine wave. One problem you might have is, like, say you can detect peaks. Um, if you're just trying to find what's the distance between two peaks, you could pick two. You could pick peak number 1 and peak number 3, for example, by accident, and then you would get a wavelength that is too big. It would actually be like twice what it should be. So you want like the minimum. You want the minimum one. Um, if you were doing some kind of peak finding algorithm, which I don't know that I am going to do that. I might just do a completely different thing, which is probably like much slower. I don't know. Let me think. Let me think. Would a peak based algorithm actually be super simple? Can I implement that in a really easy way? Hmm. Well, I can certainly find the max or min in the sequence, but there's a bunch of like near peaks that are still considered peaks. You know, it's not going to be a perfect sine wave. Uh, no, I don't think that's going to make sense. So I'm going to go with my stupid method. Um, yeah. So I want. Here's my strategy. I want to generate a perfect sine wave and try to match it to the. Oh shit, hold on. That wouldn't work. That probably wouldn't work because it could just be out of phase. Ah, dude. It could be out of phase and then I'm done for. I was gonna try to like iterate over a bunch of sine waves and find the one that fits best. But the problem I have with that is, what if you have the sine wave with the exact right frequency, but it's just like exactly out of phase? It's just like shifted to the left or to the right. That's a problem. That wouldn't really work. I might Google for a minute and see if I find anything. kind of thinking of it like a time series. And you're trying to find the seasonality, that could kind of work. The difference between a y value and a lagged value of y. So I could, you've got like a waveform, and if you take the difference between a y value and another y value with some x in between, if you have the correct frequency, then it will always be 0. Yeah, that could totally work. Aha! That must be that's the answer. That is the way. Do you know the way? That is the trick. That is the answer. I have it. It is on this weird transformed version of the thing. Do I even need to... Do I need to transform it? I don't think I actually need to do this transformation for this to work, which is pretty cool. I can still... I mean, it's still cute for, like, the visual effect. But I don't actually need to do this for that to work. Okay. So it's gonna be... My frequency is gonna be something in units of samples, I think. Yeah. It's gonna be like a wavelength. So, let's see, it's like 4... No, that doesn't make any sense. What's the max it could possibly be? Sample neighborhood? So what I want to do is I want to find the lag that gives us the least difference between the two. Imagine like 2 pointers marching along. I want to get the lag that gives us the least difference between those 2 pointers. Yeah. So for each lag, I'm going to iterate over all the samples in our window. That's not correct. Okay. Yeah. And it doesn't matter what the amplitude, like what the max amplitude is, um, because we're gonna compare a bunch of different lags, but it's all over the same window. It's all over the same thing, so it's all already normalized in a sense. If we're just trying to pick the least. Okay, so oh gee, what do we want? We're gonna try to get an average though, because we could like mistakenly give one an advantage. Okay, so what we're doing is we start this at low plus lag, so that we can then do samples I minus lag. Yeah. And then we're gonna do math.absolute value sample minus lag sample. Lag samp. I'm thinking. Residual is that's what we want, and then we want like a sum. These are going to be fairly small numbers, so it's fine to add them up, I think. I could calculate exactly how many residuals we're going to have. But I'm worried I wouldn't do it right. Dude, come on. I keep finding new ways to misspell the word residual. What a disaster. Okay. Oh, this needs to go here. Else, so then this is, oh, this is the same thing. Oops. Okay. Let's do it this way. There we go. Now we've got min residual defined as this. Yeah. Great. Cool. Then what happens next? We have the optimal wavelength now. In units of samples. So I guess we could just convert that to, like, we could convert that to units of like frequency. We could try to do that conversion to hertz. Um let me try that. Let's think about that. We don't actually have to use that in order to convert it to like a color, but we could. Yeah, we could do that. So we have, let's say we have, the answer was, what could the answer be? Let's say the answer was 100. That would mean that the wavelength of our sine wave is 100 samples. Okay, so we could just convert samples to seconds, right? So we have wavelength in seconds. So we say lag divided by samples per second, which is sample rate. So that is the wavelength in seconds. And then do you just do 1 over that? Do you just do 1 over that? So if you have one wave every 2 seconds, that is a 1/2 hertz frequency. I think that's right. OBS disconnected, and then it reconnected. Okay. Thanks, OBS. Cool, very cool, dude. I trust. Let me go check the YouTube stream to make sure it still thinks I'm streaming. Yeah. Yeah, we're good. We're good. YouTube still says I'm streaming. Okay, so I don't have a lot of confidence in this cute little frequency calculation I've done here, but I think it's right. Okay. So now we just do the color thing like we've always dreamed of. Wow, converting a number to a color is actually going to be weird. We could do. I've done an interpolation between two colors before. That's pretty cool. Yeah, we could try that. This is probably exactly how I wrote my last color class. Would not surprise me if this was an exact copy. Okay. Ratio times end dot red minus start dot red and plus start dot red. I think that is the trick. And then we do this 3 times. Oh gosh, we could do like alpha as well. I'm not gonna do that. Cool. And then what do we do here? Let start color equal new color. It's mad at me. Oh no. Okay, it's fine. It did import the class. Let's do like red to purple, right? That seems reasonable. What's half of 255? Oh, it's like 127, right? It's half of 256, basically. I have a sneaking suspicion this might actually not look that great. So we do interpolate colors, start color, that's not what I want to type, start color, end color. And then the ratio, here's the real trick, right? We don't know what the min and max frequencies are going to be, do we? So we kind of have to guess. Let's say 200 to, well, I guess 20,000? Because our sample rate is 44,000? Oh, this is not this is not wise. Doing like 5 function calls in a single line. What could possibly go wrong? I'm sure this will just work. Right? All this code we haven't tested yet, I'm sure it'll just work. I'm just the best. What can I say? This doesn't seem quite right, though, I have to admit. Oh, okay. One thing I did wrong that I just noticed is purple is not red plus green. Right? Purple is not red plus green, it is red plus blue. I don't know what I'm seeing, honestly. It's interesting, don't get me wrong. Yeah, it all pretty reliably looks like the same color. It's super cool, but no. Something... Pretty sure some combination of things is wrong. Either it could be that, like, in addition to some piece of common wisdom that I remember seeing in a Stack Overflow, which is like frequency is not a linear thing, it's like a logarithmic thing, which could make a lot of sense. That's no problem, we can certainly fix that. It's just, I don't know, let's first try to test this thing. Can I stick it in a function so I can do testing on it? That might work. It's pretty functionable, I think. This is all in the draw. This is all in the draw function. What have I done? Okay. Cool. Grab this. Stick it in the function. We're in business. I'd like to just be able to pass in an array. Maybe I make this even slightly dumber and just return the best lag. Can I get a subset of an array easily? That works fine. Okay. We give it our sample window. It gets the best lag. We get a best frequency. So I claim that nothing should have changed after having made that conversion. Am I gonna see an occasional red waveform like I was seeing before? A little bit concerned. Oh dear. I might have broken something. Okay. What I should probably do, for starters, is print out the best lag. And see, are we getting approximately reasonable numbers? No, we are not. We are getting a bunch of 2s, which explains why we're not getting a much fun variation. Ah! Okay. Maybe it's a simple bug. Okay. If min residual is undefined, or average residual is less than min residual. Okay. So why would 2 always give us the best? Why would 2 always be the best? You know, if the window is like particularly chaotic. Yeah, if the window is particularly chaotic, then what's actually happening, like I actually think this is working correctly. But what's probably happening is the time series is correlated with itself. Okay, so if you take a lag of 2, you're not looking that far in the past, and so the values are probably going to be pretty close to each other just by happenstance. Yeah. So if 2 is not a viable answer, it means that we will have trouble with high frequencies, I suppose, using this method. But most songs don't use that high of frequencies. Huh. Like, what if I choose 4? Okay, I compromise, I choose 4. If I choose 4, I get 4, it seems. Huh. Just a bunch of 4s. 4 forever. Okay. What if I print, What if I print out the lag together with the average residual, just to see if there's not something silly going on there, right? Okay, we come up here to the top. What do we see? We see a lot of very small numbers. It's probably very small numbers because at the beginning there's not much sound happening. Huh. Okay. That testing method is not great. What if... Okay. This is crazy. What if I trick my code into thinking it is seeing something it is not? Aha! You know what I'd like to do, though? Is stick this here and just use this everywhere. Everywhere there's a for loop. Right? This will make the tricking I'm about to do so much easier. Okay, I think that completes the substitution. Let me run it again to make sure that I have done that correctly. Yes, I believe I have. You know what occurs to me is the coloring based off of the lag might actually be nicer. I mean, it's gonna be the same color every time. We already know that. Okay, it still runs, yes. Okay. And now I can do what I was attempting to do, which is replace this. Where is it? Where is it? Okay, replace this sample window with a dummy. Okay. And do that, and then come over here and write this function. Ooh, can I actually return a float 32? I'm gonna return a number array, because that's kind of all I know how to return, but that's not gonna make it happy, is it? TypeScript is gonna be so mad at me. Trying to pass off a number array as a float 32 array? Tisk tisk. Huh. Wait. No, it's mad. It's mad. It's so mad. Oh my god, it's so angry. Aha! Problem solved. I have no idea if this is going to be right, but let's see. So we choose any file, it doesn't matter, and it's it's a complete disaster. Oh my god. So I believe the frequency is too high? Question mark? There were multiple things there. I want to change this console.log thing to not print here. And I want to mess with this. Okay. So this is in units of radians. I'm gonna iterate from 0 to a couple hundred. So let's divide by okay, yeah, let frequency 1,000, I guess. I'd like to just be able to change the frequency. Oh geez. Right, this is we have the sample conversion problem again. Uh oh geez, what am I gonna do? Um so it's like sample number, I is the sample number, right? I is the sample number. If we divide by the number of samples per second, okay, so we've got 0. It's like, imagine it's a second, right? Okay. So we're going to iterate 0 to 44,000. And when we get to 44,000, if we have a frequency of 1, then we should expect to complete the circle. So it's this this times 2 pi. Times frequency. I think that's correct. Oh, I should increase this. Yeah, that looks right-ish. And it's getting wider, and then it's going to get less wide. Yeah, that's kind of what we want, I think, approximately. Perfect. Okay, so the fact that I'm giving it a perfect sine wave, and it's still like, I don't know what the frequency is, that's a problem. Right? That is a problem. That is a problem. So we need to stare at this misbehaving function that we have here. What is its problem? This should just magically work. I thought it up in my head. Why doesn't it work? Plus equals residual. And we're adding up how many residuals we count. And then we do the division to get the average. Yeah. Okay, let us stare. Let us stare at this. This is the average residual that we get for 4, 5, etc. And what do we expect the correct answer to be, right? We expect it to be, I don't know, like 30 or something like that. 0.002. It seems to go down a little bit here. Four should be... Okay, I'm gonna come back over here. And now I'm really paranoid. I want to log like the actual sample and the lag. Sample, lag sample. Okay, so it's very nearly 0, which I think is kind of what you'd expect because it's down over here. And let's see. It should be decreasing. What? What? Why is that what it's showing for the samples? Excuse me? Oh, okay. Check this out. Check this out. My FPS says it's 1. Which I is very strange. Oh, I know why it's 1. I know it's why. It's because I didn't increment the log counter. So actually my computer's dying. Oh, my poor computer. Oh, I must close the window. I've done it again. Okay. I fixed it. Okay. So here's one problem. I claim. And it's that this variable... so annoying. Okay. This is a globally defined thing, so it's this actually should not be. This should be. Finally, I've seen the bug. I've seen the bug. That is the bug. Okay. Delete all logs. Delete all logs. We found the bug. Just gonna make sure it's not hiding elsewhere. Okay. Wait, what am I drawing? I'm drawing the, what am I drawing? Sample window. Right? Sample window. Yes. Okay. I think that's correct. Oh, I need a I need a new browser window. Need a new browser window. Okay, it's there. It exists. This actually isn't what I want to see right now. I mean, actually... Okay, I could bring back in the, the changing frequency trick. Yeah, look at that. It should be changing color. It is cycling through a bunch of different colors, which is actually not what you want. If you can believe it. Huh. What's that? What's the deal with that, I wonder? Let me bring back the best lag print statement. Weird. That's not right at all. Look at how not right that is. Huh. I bet this would look pretty cool because it's kind of just a random number generator, seemingly, at this point. Why is it doing that? Wait, so is this... Is this actually the issue that I thought of before? Where it... Oh, this is totally that issue. Oh my god, this makes so much sense. Because this is like approximately... The things that it's alternating between are like halves. And triples. Yeah! That's totally what it's doing. Oh, that's great though. That's so great. That's actually fantastic. And the slight differences come from the fact that like when you're adding up all these residuals, it's gonna be like imperfect. So you're gonna be off. It's like even if you have almost the exactly correct thing, it's not gonna be perfectly correct. Okay, so my question is, can I do a quick console.log of the actual residual we're getting when we're testing this? Yeah, let me do that real quick. So I can, what I'm gonna program in is some kind of tolerance for things to be considered equal, and that might work. Okay. What am I console.logging? I'm console.logging lag, comma, average residual, I think. Yeah, that's what I'm console.logging. This is such a better error to be having, though. So happy. Okay. Yeah, check it out. That's a reasonable average residual. Yeah, look, check out how basically perfect that is. E minus 16. But, okay, 48 times 2 is 96. I bet if we come over and look at 96, almost exactly the same value. Yes, and if we come over and look at 48 times 3, which is 144, we see that again. Yes! Haha! Oh, dude, this is so great. Alright. We come back over here, and we know what's up now. We absolutely know what is up now. And what we're gonna say is, if min residual minus average residual is greater than... Okay, what do we assume here? We assume that average residual is less. Okay. But it must be more or less... than that. Must be that much more less. And now, get rid of this. now we bring back, we show just our original print statement. It should not be stuck at... Okay, this is actually not right. This is incorrect. Huh, I thought that was going to be it. If I reduce this tolerance... Is that what we need to do? Is that what's happening? No, it's still... What if I do this? More! Nope. So what I think is happening is as we stretch out the wavelength, the lag that we're guessing is just more and more slightly off from the exact right number. So I have to fiddle with this until it actually accepts a certain amount of error. That seems like it's not helping. Oh no, that might kind of be working. Oh? Yes. Yes. Perfect, 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 perfect. Less than perfect, less than perfect. Huh. Once it gets too wide, it starts confusing itself. A little bit. Huh. That's pretty weird. Okay. So one thing I want to do real quick is this tolerance that I've programmed in here seems to be working pretty well for like most of the frequency range, but it will be sensitive to the possibility that the amplitude is really low. So actually we do want to bring in this concept of like an amplitude scaling thing. because I claim that will help us. That will help us do this better. Lag sample is equal to... So we do times, or divided by max amplitude, I guess. Yeah, which should make it bigger. Cool. So perhaps doing that alone has a significant change and helps us. It at the very least should make it worse, I hope. Oh shit. Actually, maybe I could imagine why... Maybe... Okay. Huh. I'm gonna try 0.2. 0.2 might be a little bit too aggressive. No, it starts freaking out at like 70. I could keep fiddling with this. Let's see. So, I'm kind of surprised that this works, though. Huh. Maybe I need to be a little bit smarter about this, right? Maybe if I store all the possible lags and their residuals together, and then like sorted them, and then like picked. I should impose some kind of penalty for choosing a higher lag. Yeah, I should impose... Okay. So, that's fine. That's kind of okay. So yeah, so what I'm gonna do is I'm gonna print out all of the lags that we tested, sorted by... Yeah, so actually I'm just gonna abandon this... Actually, no, I'm not gonna abandon that. I'm gonna leave that in there. But I'm basically going to be abandoning this concept because I'm worried that this only works so long as we're starting our lag at 4, and that just doesn't feel quite right. Like, this number is actually getting really high. Yeah. We have like I'm pretty sure I'm right about that. Okay, so how am I gonna do this? We need a compare function. Does this do it in place? Yes, it does. Okay. This is totally gonna work. Yeah. So now, yes, we're getting the top N lags, the top 4, I guess. It's kind of weird that down here it's doing worse. Like, the average residual is... Huh, interesting. There's actually a pretty big difference. $75. So the correct answer here should be like 75. But what's crazy is, look at how much better the 147 is. Right? That's crazy. That's very concerning. Oh my gosh, okay. What if, rather than trying to mathematically impose some kind of penalty, we literally just return the minimum of the top 4 best lags. Oh my gosh. How silly would that be? I'm doing it. I'm doing it. That might work. That might just work. Oh my gosh, that might just work. Okay. Forget this. Forget that. Forget this. Delete this log statement. We will return the... Can I use an array? Maybe. Flags 0, flags 1, actually, dot lag. Okay, this is mad at me because it wants this. And then it's happy. Yes. This feels so janky, but it might actually be really good. Okay, let's see. That's insane. Yes. Yes, it works. What's the lowest value? We saw 48 before. It's just going to go back to 48, I assume? Yes. Yes, dude. Oh my god, yes. Okay, let's sweep over a larger frequency range. And also, can I switch up the color? No, maybe the color's fine. I don't know. Actually, one thing I want to do is I want red to be low frequency and purple to be high frequency, and that doesn't work so well. Oh, hold on, it messed up for a second there, didn't it? For a split second it messed up. I love it. It's unreasonably good. Okay, and we switch up the colors. It's great. It's great. It's great. I love it. Okay. And then I'm gonna go turn off the fake sample generator. And we might cry because we find out that it's just not good at real life frequency detection. Which would make me very sad. Honestly, I think it's good. I think more likely the coloring on it is just bad. Yeah. I think it's potentially really good. I don't know. I'm hesitant now. I'm like a little bit skeptical. Well, wait. Okay. Is there a bug happening? Let me stare at the code for a second. Sample window is still this. Okay, so that's fine. I could console.log the best lag, right? I could do that. Oh dear, I'm getting a lot of 4s. Okay. Okay. That's fine, I think. I think I know how to resolve the 4 issue. And it's to start the lag testing at a right, because I picked a min, so actually we pick like 20. We start the lag at 20 as like the highest possible frequency we could anticipate. And if that's the case, I can mess with the map linear thing, the coloring. Yeah. I don't like it that it keeps defaulting to 20 too often, but it's certainly an improvement. It's a big improvement. Let's try 30. Obviously, if we go too high, then we're not going to be able to distinguish high frequencies. I think it's pretty good. I think it's pretty good. Let's pick another random song. Oh, awesome. Okay. Yeah. I'm loving it. I'm loving it. All right. I'm gonna play for the end of the song and then I'm gonna head out. Yeah, that was interesting. I think actually the super low frequencies uh don't get handled very well because the window is actually so small that you don't get a whole wavelength in there after staring at that for a while. But yeah, I'm gonna head out now. Thank you for watching. I will hopefully be streaming tomorrow as well. Made a lot of good progress today. I'm pretty happy about it.